Hello, in this short video, we will have a look at Evolved Packet Core, which is the core network of LTE system. I will try to give short overview of EPC architecture and explain its key elements. Having general understanding of EPC will help you to understand 5G journey as pillars of 5G has been introduced in EPC architecture previously. Now, I would like to tell a couple of words about circuit and packet switching. In GSM, the architecture is built on top of circuit switching. Circuits are established between the calling and called parties in advance through radio and core network. In GSM, all services are transported over circuit switching system. With introduction of GPRS, packet switching was added to circuit switching. Data started to flow in packets without establishment of dedicated circuits. Circuits still were transporting voice and SMS. Therefore, the core network was composed circuit and packet switching domains. In UMTS, as successor of GSM, this dual domain concept has also applied on the core network side. Some network elements have evolved, but concepts remain very similar. When 3GPP community started designing the next evolution of the UMTS system, which will be called LTE, they decided to use IP to transport all services. That's why EPC doesn't reside in circuit switch domain anymore. EPC was first introduced by 3GPP in Release 8. Flat architecture was intended for EPC. Main task was to handle data traffic efficiently with increased performance and reduced costs. It was also decided to separate the user data and signaling to make the scaling independent. Separation of control and user plane made dimensioning easier and brought centralized data packet processing to network edge. Separation of control and user plane was introduced with LTE. 5G took it to further. This concept is a very important milestone. It made possible for telco world to embrace cloud technologies with decentralization and horizontal scaling capabilities. Here we see high-level architecture of EPC. User equipment is connected to EPC over LTE radio access network. The evolved Node B is base station for LTE radio. EPC composed of 4 network elements. Those are MME, HSS, Serving Gateway, and PDN Gateway. In next slides, we will go over them one by one. The Home Subscriber Server is concatenation of HLR, Home Location Register, and AUC, Authentication Center. These two functions are being already present in GSM and UMTS. The HLR part of HSS oversees storing and updating all user subscription information, including user identification and addressing, user profile information such as service subscription states and quality of service information assigned to the user. The Authentication Center part of Home Subscriber Server generates security information from user identity keys. This security information is provided to HLR and further shared to other network elements. Security information is mainly used for mutual network terminal authentication, radio path ciphering, and integrity protection to ensure data and signaling transmitted between the network and terminal is neither eavesdropped nor altered. Serving Gateway with Packet Data Network Gateway reside in user plane. They transport IP traffic between user equipment and the external networks. Serving Gateway is the point of interconnect between radio side and EPC. It serves the user equipment by routing incoming and outgoing IP packets. It is anchor point for intra-LTE mobility and between LTE and other 3GPP access technologies. Anchor point is meant to maintaining a common connection point as a mobile device moves through radio coverage areas that have different connection points. Serving Gateway is logically connected to Packet Data Network Gateway. Packet Data Network Gateway. The PDN Gateway is the point of interconnect between EPC and external IP networks. These networks are called Packet Data Network. The PDN Gateway routes data packets bidirectionally between PDN and user equipment terminal. The PDN Gateway performs IP address prefix allocation. PDN Gateway also supports policy enforcement features as well as packet filtering and evolved charging support. 3GPP specifies these gateways independently, but in practice they may be combined in a single box by telco vendors. Mobility Management Entity. The Mobility Management Entity performs control plane functions related to subscriber and session management. The MME is linked through S6 interface to HSS to fetch or update user subscription information. MME supports security procedures for end-user authentication, as well as initiation and negotiation of ciphering and integrity protection algorithms. Terminal-to-network session handling, related to all signaling procedures used to set up packet data context and negotiate associated parameters like quality of service. It also provides tracking area list to user equipment and performs paging to notify user equipment about various radio access network events. MME is the key network element in LTE core network. In 5G, it is decomposed as two separate network elements to make them scalable independently. In this section, you will find a bit more of detail as scope of MME wider than other network elements. MME is a bit complex network element and touching all aspects of control plane. Let's continue other functions. Bearer activation and its deactivation procedures by choosing the serving gateway for a terminal in process of initial attach and when intra-handover takes place. Termination of all non-access stratum signaling. Ciphering and integrity protection of NAS signaling. Authorization of terminal to PLMN and enforcing roaming restrictions. Lawful interception of signaling. Control plane function for mobility between LTE and 2G, 3G networks by S3 interface. Hope that I could be able to shed the light on EPC. Please let me know about what would you like to listen on next episodes or your thoughts about the topic. Feel free to share your comments. Thank you very much.